I'm a data scientist at Dell, and I'm going to kind of walk you through a use case that we've worked on and kind of like the ups and downs, the path of getting this particular project out the door. So most people, when they talk about developing models, you start with, you have a concept, magical things happen, it goes out the door, it's in production. I think we all know it's more complicated than that. The development process, you raise all sorts of questions, you have brilliant ideas that you iterate on, it becomes a lot more of a gnarly process than you expected it to be. It turns out the same thing is true for the productionalization part of the process too, right? You have to think about things that during the modeling part of the process you weren't thinking about. You have to figure out how to scale stuff. So there's just all kinds of considerations that maybe at the beginning when you had your wonderful idea, you hadn't already thought of in advance. And so it's kind of a little bit more of a windy path than maybe we expected at least. So set up what our concept for this project was. The business problem we're trying to address is how can we streamline the tech support experience at Dell? So we have a customer with some sort of problem, they call Dell, and there's one of two things that can happen. You can either fix it remotely via code, patches or updates to drivers or something like that, or you have to send a part and physically fix something. So there's lots of places in this process where we can streamline it and make it better. So first of all, the customer is describing the problem, and then the tech support agent on the phone has to get from my cat is sick and puked on my computer and now my screen isn't working and my keys are sticking to, okay, the keyboard has issues, right? So distilling what the customer is actually saying down to what's the repairable problem is part of the process. So they have to summarize what's going on, and the time it takes to get from what the customer is saying to what the problem actually is something we can streamline. Once you have an idea of what the actual problem is, there's a bunch of troubleshooting guides, right? Decision trees that they walk through with the customer to figure out, did you turn it off and back on again, all of those sorts of things. But based on what they guessed the problem was and what options they have available to them, it may not be obvious at the beginning what the right decision tree is even going to be. The way that this worked previously is basically it's just one big web page of links, and a lot of them are pretty close to synonymous sometimes, and so it's hard to know where exactly is the right answer even going to be. So that's a place that we can make better. We can also, because that's a little bit confusing sometimes and not streamlined, we can make that process faster hopefully as well. So then, okay, now I've gone through some process of trying to diagnose what the problem is, and I've come up with a potential solution. So getting to the solution faster, maybe not having to take as many steps through that diagnosing process is another place where we can get some more efficiency. And then also, is it the right solution? Trying to get to the right solution faster more often is one of the places we can make it better. And then also, from a perspective of the customers and Dell, if I can call in and get my problem fixed then on the phone, that's better for everybody than we have to send somebody out to your house and actually fix your computer. Or you have to bring it in somewhere and leave it for half a day and then they'll get it back after we fix something. So it's in our interest, if we can find software solutions to problems, to push those over hardware solutions if they work, if it actually is a valid solution to the problem. And so these are all steps in this process that we were attempting to try to make optimized in this project. So our development process, we started just make it exist, make it quick. So we took one particular laptop brand that we sell in the US and in a month turned around a model to say can we predict some of these things and get some efficiencies in these pieces of the chain. This is what we ended up making. So on Domino, we built a Dash app. All of the models were trained just straight scikit-learn in Jupyter notebooks. So this is a Dash app where the agent could type in the service tag, the identifying ID of the product, and then whatever the problem is. It does some live NLP, keyword extraction, and issue classification, and then there's two prediction models for what the diagnosing tree is going to be to actually solve the problem, and then what the likely solution at the end of that is going to be. So this is where we started. And in the process of doing that, so just as these little stars throughout, just kind of tips and things to be aware of. If you are building a Dash app on Domino, there's some configuration and syntax stuff you have to get in place, and it's not terribly well documented elsewhere on the internet. So we worked together, and I wrote a guest blog post for Domino of how to set that up to get it to work on their servers and everything. So, so now we have this working demo. We can show it around to execs, get some buy-in from people, and we got approval. Okay, yep. Let's go ahead and pilot this thing. Let's get 1 to 2 dozen agents. You know, get some people, roll it out. We didn't have any infrastructure in place for deploying this stuff in the first place, and so we were more than just testing this model. We were testing putting models out there at all, because this isn't something that our chunk of Dell has really done in the past. And then also the infrastructure and just having the web app interface with the other Dell tools and all of that stuff. So we were going to start small, test it out on some people. So then, okay, now we have buy-in, let's make it better. So we expanded our training data to include all of the product lines that we sell. We expanded to all the large English-speaking countries, basically, that we had in our data set that covered all the major regions that we service. So US, India, Australia, New Zealand, and UK and Ireland are represented in the data set. We took 5 months to train models to do more products, more different kinds of problems, expanded on the feature set that we were including, just did a bunch of the normal development process that you would expect. At the same time as, another tip, so one of the things that we did to make it better as well is we actually converted our models from the scikit-learn implementation into this Revoscale PI Microsoft implementation. So if you're looking to try to do that, the actual package is called Microsoft ML, but all their documentation is written as Revoscale PI. So if you're looking around on the internet for that, those are the things you would look for. So we imported this into our Docker environment that was in Domino. And then the thing that it gives us is we had some models that were training in about 4 hours, which is not terrible for machine learning models, but we were able to get them to train in like 5 minutes. And what happens in this Revoscale PI implementation is that you take your single-threaded implementation from scikit-learn, and it's all parallelized in this Microsoft space. And so it makes it really, really lightning fast. The downside of this is that it basically has no Stack Overflow presence. And so troubleshooting and getting things off the ground and getting through the documentation to implement it is more of a struggle than with some of the more widely used tools that are out there. So that went so well that we were told, hey, how about instead of that couple dozen people you were going to try this out on, let's roll it out for like 300 people. And we're like, whoa, that's not what we built this for. Let's test it on scaling and like look into what that means. And so the web app that we had that I showed you a bit before was getting something like 500 milliseconds response time and could handle about a dozen concurrent users before we started getting server errors and things like that. The big goal for us was getting under about 300 milliseconds response time. That's the canonical value for web lag for apps and things before people start to disengage with it. So now, okay, we need to make it scale. Then what do? We have to think more about productionalization. So we reconfigured the front end. It ended up looking like this. So we still have the same entry points, that service tag and the symptom description. We do the live keyword extraction, and then we have, and now instead of 2 models, we have 3 models. We actually split one of them apart to get a little bit more predictive power, and then we have a very clear next best action for the agent. So instead of trying to like look at all this information and make a decision about what models mean or whatever, we're trying to give them a much more directed, like it's there for informational purposes, but we'll give them like, this is what we think you should do. So when we implemented that front end, we also split up some of the architecture. And so what we did is, rather than having all of that functionality in the Dash app directly, we split all of those calls out to APIs. And so the keywords API, the product lookup API, and all the models became APIs. One of the other things that we had to end up doing was there was some weird functionality with getting Internet Explorer compatibility, which, because we're at Dell, we still have people who have to have Internet Explorer compatibility, and so we had to design around that. And so we hid some of those APIs behind a submit button rather than just having it as it was before. Dash is stateless by design, and so whatever's on the screen is live and all up to date, concurrent with each other. And so that means every character stroke, all of these APIs get hit every single time. And so it was just a big load on the system that didn't really need to be there until they had finished typing. And so that's why we implemented the submit button there. And so by breaking it up like this and kind of restructuring what we were doing, we still were kind of in the same range for our response times, but we were able to get more users. So now instead of having like less than a dozen and we're barely getting that, now we can easily have a dozen and it's fine, but it's still clearly not enough. Like this is not gonna get us where we need to go. So then what we ended up doing, we realized the actual bottleneck in the process is the Dash app itself. Part of the way that the web app infrastructure on Domino was working with all of these API hits that were happening is was making it so that they were basically single threaded. So all of those hits were requests stacking behind each other. And so if you had a lot of people at one time, it became hard to handle. So what we did was we moved the web app off of Domino onto an on-prem, well, our Domino instance is on-prem too, but we moved it onto a freestanding web server running Microsoft IIS. So that became our web app server, and we still had all of our APIs deployed on Domino. You can see here that we boosted our number of users. We were able to get multiples of dozens of users fine. It was totally working, but our response time still didn't really get any better, and we were actually trying to make that better too. And so what we ended up doing to address the response times is redeploying these APIs in Azure Machine Learning Server functionality. So the ML server has a deploy API functionality, when we restructured our solution this way, we've now tested with up to 170 users, and it's all working fine and nothing's broken. But you can see that our response times are 1/10 of what they were before. And so it's lightning fast when you get it working. Again, same comment I have from before about the Revoscale PI stuff. The Microsoft things that we put in place for this project, when you get it working, they are lightning fast and really useful. The struggle to get them working is just not as easy as some of the other products that are out there. And so, I mean, we had, Wes McKinney talking about open source and documentation, and like your ease of use of the thing is part of the point. And so this delivers on the performance part, but the ease of use is harder. And so the other thing that we ended up finding is that the errors that whenever you would have troubleshooting errors with deploying the APIs, the errors that were passed to me in the Jupyter notebook at the time of deployment were not the same as the errors that the web server itself was logging. And so I had to have the guy on my team who's the admin of the server, like, what error are you seeing reported, so I can diagnose it, so I can fix my API, so that then he can check and make sure that error is not happening. And so it was just a little bit more of a hassle to get through that than it had been on Domino. The good thing about this is, again, this whole process we were road showing and getting more buy-in from various levels of execs, because we needed tech support managers on board, we needed the people who do parts stocking on board, because if we changed the distribution of which things were getting repaired or shipped out, we needed them to be on board with the fact that that might change. And so we continued to roadshow this around and get buy-in, and now we're being told that maybe 3 months from now they're going to want to roll it out to 10,000 people, and we're like, whoa, that's really big, really fast. But in principle, now that we've got everything into this Azure functionality, putting it on actual Azure should be a forklift operation, hopefully, fingers crossed. So that's kind of the evolution of this project and where we got with that. So I wanted to kind of just summarize what some of the key takeaways were from me. So this was my first opportunity using Domino, was on this project. And one of the things that I just truly, truly loved about it is that, like, over there on the right, like, literally that's what you do to publish an API. Like, here's my script, this is the function in the script I want the API to use, publish, done, and it works. And then it gives you like a code snippet of like, here's how you call this API in Java, here's how you call it in Python, here's how you call it in all of those different languages. So it's just like immediately usable. That stuff wasn't nearly as easy as that with Microsoft. Again, like the performance is definitely there. The other thing about the Microsoft stuff that I wanted to say is that a lot of the toolkits that I had been used to using before, just the standard pandas, scikit-learn, all of those implementations, I think the open source community has done a really good job of making like standardized inputs and outputs for all of those things so that they play well together, and so you can plug and play with a lot of it. And The Microsoft inputs and outputs are a variant of those, and so you have to kind of reconfigure your input data and reconfigure your outputs to be able to combine it with the pre-existing stuff you had before. But again, it's not hard, it's just a thing that has to be part of the process that I hadn't expected at the beginning. So that's kind of what our whole process was and what the takeaways are for me. So again, the other part, when we originally scheduled this talk, this product was supposed to launch on May 7th. It launched yesterday. So I've been sitting during the conference yesterday, like, how's everything going? Give us some stats, like what's going on? It turned out everything went fine. There were a couple of little, like, some known issues that came up and some, like, I don't know why the model's giving me this output, but it's not a major deal kind of feedback, but the response, the productionalization part of it has totally been solid and been there. We haven't had any usability issues. We've had, like I said, 170 people using it yesterday. Some of the feedback that we got is that about those specific paths, the troubleshooting guides, I'm getting paths that I didn't even know existed. So they're finding ways to solve problems on the phone that literally they didn't even know about, even though they're existing agents that had been there and doing this for a while. Another one was earlier we used to have to search through a list of variable paths because they were constantly updating it and changing it and utilize a find command. Now it takes me directly to the relevant place. It's great. And so this is, I was really, really, really pleased to get this email yesterday. I felt like it was a really good testament to exactly what we were trying to do. And there's been a lot of really good talk at the whole conference about like working together with your stakeholders and having a really tight communication system. And I think we've been trying to do that as much as possible to get like word from the floor exactly what it is they want and what will be useful to them. So the overall metrics that we're going after with this project are shorter call times because we get to solutions faster in some cases. In places where it's possible, we can send fewer parts because we can diagnose issues that are actually solvable via software. Hopefully better outcomes because we've trained all of these models only on cases where we know that the customer ended up getting a solution. If we sent something and it didn't fix the problem, we didn't include that data so that we only have good examples of what to predict on. And then all of that together also should help our customer experience scores because it gets them off the phone faster, gets them a solution faster, hopefully makes the whole process a little bit more streamlined. So one of the other things we wanted to do with this talk is because we kind of talked about the evolution of this process on Domino specifically is where we started, and we talked about some of the limitations we came across. I wanted to introduce Rob Seaman, who is going to talk a little bit about like what Domino is actively working on for those specific issues.
Who here uses Domino today? Okay, a pretty good chunk of you guys. I want to go back to one of the slides that Randy showed earlier. So they did a lot of very cool stuff, but I would argue they did a lot of things they didn't or shouldn't have needed to do in order to achieve scale of this Plotly Dash application that they built. So I'm going to spend some time talking to you about our product plan from a Domino perspective, to explain how we plan to address some of those issues, but more broadly how we plan to address the productionalization of models in general that come out of Domino. Those of you that were in the discussion this morning, or not the discussion, but the presentation this morning that Nick gave, this is the decomposition of our vision for model management. I'm not going to walk through every part of it, but a very large part of it, and a very large part of the future of the Domino, is this launchpad area. And this is where you will basically get models into production. And models can go into production in a couple forms. They can be in the form of interactive applications, like what Randy showed you just now, that business users use to find answers or to get predictions about what might happen or to diagnose certain issues. They can also be in the form of APIs. From Domino's perspective, we want to give a very smooth vehicle for you guys to publish those things to production, understand how they're performing, get feedback on them from their consumers, and get them into a place that those people can actually find them and use them. That's something we hear in spades from our customers, that they publish a model in the form of an app or an API and they don't actually know if people are using it. So we're doing a few things to address that larger opportunity area for us and some of the tactical problems that Randi and Dell went through. So from an infrastructure perspective, like most people, I think in modern software development, we're making a really large bet on Kubernetes. Took me a while to spell that title last night. I still can't say it, so I'm not going to say it. Moving to Kubernetes gets us three things across applications and models deployed as APIs, which Randi used both of at Dell. One is fault tolerance. So when you deploy apps in Domino today, you can encounter some of the issues that Randi ran into, where a lot of the requests will get single-threaded, bottlenecked, and people will have to wait. By moving to Kubernetes, we can make these actually more multi-threaded and solve for some of the fault tolerance issues that we've had previously with published apps. It also allows us to scale for concurrency. We've seen a number of our customers will do something like what Randi does, typically not as involved or sophisticated as what Randi and team did. A lot of people, like if it's a Shiny app as an example, they go off and actually pay extra money for Shiny Server Pro to achieve the levels of concurrencies for their apps. And we're increasingly seeing people put apps in front of more and more people. We're also seeing increasingly that research firms, syndicated data firms are wanting to put apps outside their firewall to their customers. And inevitably that's going to mean a larger number of users and the need to achieve more scale. We're planning to move our app infrastructure over to Kubernetes over the course of the next few months, which will allow us to achieve that fault tolerance and allow us to achieve concurrency to the scale of things Randi was talking about and others would like. The other thing Kubernetes gets us is the ability to actually move our models on-premise. For those of you that have on-premise deployments, this gives you the ability to deploy models as APIs in an on-premise way, which is something that's been a bottleneck for some of our customers before. On the app side of the house, we're introducing an app store-like experience. We're focusing on apps to begin with, but this is actually in the 2.6.1 version of Domino. This is in the lab and development environments of some of our customers today. But for those of you that publish applications out to your business users and have to send them a URL and send a URL and don't know if they're actually using it, the App Store is going to be a place that non-technical users of Domino can come and actually discover the products of the data science team. And they can do things like faceted navigation and see things about churn or inflation or GDP or customer lifetime value and in a way find what they need that the data science team has produced. It will be governed by access controls, so as a data scientist you will be able to say who, if it's a subset of people should have access to it or if the entire population of people should have access to it. It's going to give them quick information about who created it. You're going to be able to declare as a creator some background information, release notes, descriptions. People are going to get some indication of frequency and usage when they see these things. They're going to know, who amongst the organization has actually used these things. Is it relevant to me? And very quickly be able to launch it. Lastly, one of the key things that this gets us, and I think gets data scientists as creators, is visibility into how these things are getting utilized. For an application, for a real-time model, obviously you care about drift of the inputs and outputs and things like that, but for an application, you really care if people are using it. And we're introducing something that's akin to Mixpanel for Plotly Dash or Flask or Shiny apps that are published in Domino. So when you publish an app in Domino, you're actually going to, for those of you that have not done it, this is the Domino interface. Via this publish area of the nav part, you'll be able to actually publish your apps, get a URL, share that with people, but you're also going to be able to see the usage. Here we're showing a visualization of that usage hourly over the course of the last 7 days. But I think more importantly for people is actually seeing, did that VP of sales or that head of service that you targeted this app actually use it? Who's used it? And when did they most recently use it? Okay. Lastly is on the model monitoring side of the house. This is a little bit different than apps. This would be monitoring an API-based model that may be getting stored in real time, embedded into an application or another app. Our goal is to give data scientists and IT leaders or IT people visibility into how those models are performing from a system perspective. Is it up? How is it responding? Or how is the performance of the responses? And then from a data science perspective, how is the model functionally performing? Is it accurate? Is its accuracy training? Are the inputs and outputs drifting over time? So what we're planning to introduce with model monitoring, and we're actively looking for early beta customers to help us define this, is an ability to deploy a model as an API, which you have today, obviously, but give you the ability to actually set up alerts and thresholds and define what it is that you want to monitor about that model. It will differ based upon the algorithm type that you're using, but you should have flexibility in defining what those thresholds and alerts will be based on the type of algorithm that you use, whether you want to monitor the input and output data relative to prior live data or the training data. You should be able to do that. So my big ask for you guys is, given what you've seen, given what you've heard from Randi and some of the trials and tribulations they went through, and having seen the direction for where we're taking applications, the infrastructure that supports it, the App Store, and model monitoring, if you're interested in helping us shape the direction of the product, please grab me afterwards, and we'd be happy to do follow-up meetings with you to get your feedback and help you shape our direction. Cool. I think we'll hang out and answer questions if you have any.
If the model is in production and you're seeing people use the solutions as a guest system, are you using those resolutions to feed back into the models?
I mean, it's the plan. We haven't, so we're not actually actively live retraining. We're going to be on like a bi-weekly cycle of retraining the model on newer data. We've actually done some testing on how much it matters to add like weekly new data to the training to, get exposure to the new data that we're going to be collecting and all of that. And it doesn't actually seem to change the model accuracies or the outputs very much. But the one thing that we do really want to be sensitive to is if new issues crop up that have never been seen before, we want to have visibility to those and get those into the model. So the lag of, I mentioned a little bit before about like how do we know we had a good solution to even train off of. The minimum lag on that parameter is a 7-day window of like, did the customer call back within 7 days or not? If they didn't call back, then we assume it's fixed. Not necessarily always true, but like it's the proxy we have. And so we need at least after 7 days to be able to rerun it. So a couple weeks would be enough time to have enough data to actually maybe have sensitivity to new kinds of problems. Yep.
Yes.
Yeah, I saw, I guess the question outstanding from your presentation was, I saw that you were looking, if you are looking to scale across the United States globally, and I'm very impressed with Domino, but do you feel today that the capability or in the near future that you can scale, say, like 153 million, like a real big data solution with?
Well, so are you talking about users or are you talking about how much data?
Yeah, users or?
So part of that is dependent on the hardware cluster that you have Domino installed on. And so like our particular instance of Domino was such that it was definitely not going to be able to handle that anyway. We're actually actively adding new hardware to it, I think next week. I don't know if you know the day of that, but yeah, so we just bought a bunch more hardware to expand our Domino cluster to kind of handle some more of this stuff. But I think the timeline, I mean, you can maybe speak more to what the timelines would be for that. I think for right now, that's not there. Like I said, I think if it was there, we would have used it. Because I really enjoyed working in the environment, and it was not an easy transition to get everything out of Domino. The other thing in terms of, I guess, tips and things we've learned along the way, in terms of process flow, one of the things that we found is having, despite all the wonderful version control things that and shareability that Domino does, we also have a GitHub instance. And we can use that GitHub instance to communicate between our production environment where things are deployed now and Domino where things are trained and evaluated and modeled. And so that's kind of how that workflow is working for us right now.
Regarding the scale, first I think it's funny that you want to buy hardware. Regarding the scalability.
We buy it from ourselves.
Yes, that's the funny part. Regarding scalability, we'd encourage you to push the limits and work with us on that. We've increasingly have customers that want to deploy it outside of their firewalls to broader sets of users. This move to Kubernetes is going to happen over the course of the next few months. So that's something that we're actively working on and developing.
one of the other cool things about this process was that we were talking with Domino as we were making the decisions to do all these things to try to see if we could make it work without having to shift off of the platform. And we had conversations with some of the engineers where they're like, do you want to try beta testing this like right now? And we were like, well, but it has to be working in 2 weeks, so probably not this time. But like they were really, really flexible and tried to help us get there, so.
Yes, behind.
Yeah. So in the handoff from the handoff of the model from the data scientist to the DevOps person who's managing the infrastructure.
No, all
the
data scientists.
Okay, all model is running. Is it a Docker container or is it the model code that gets Dockerized there?
No, so we actually the way that the ML server APIs work, we have the environments where we train the models, and then just within that environment, we say, here's the host, here's the port number that you're going to deploy this API to. We do all of the deployment part actually in Domino, and then it sets it up on the other server. And then the only thing that needs to be in place for that other server really is that you have to have all the ML server functionality installed as well in that place to be able to call the models from the front end. So the thing about the Domino APIs have all the code snippets for how you can consume it from other languages, but it really, the call for the API, at least the way that we've instantiated it this way, requires that ML server functionality to both deploy and then call it.
So the way you did it, is this, because it seemed like it was a prototype and then going to production, is this something that would scale in that if you have all these teams within Dell who want to do this, and then will they follow the same method?
Like other data science teams, should they develop this way?
Yeah.
I mean, I think one of the gratifying things about this conference is that I've come away with a sense that everybody's figuring it out as they go, which makes me feel a little bit better that we've been figuring it out as we go. I like to describe Dell as being broken into 3 parts. There's like making machines, there's selling machines, and then there's everything that happens after a machine is sold, so warranties and repairs, and obviously we're in that services part. And because it's siloed, nobody had really done this in our chunk of Dell before, so we didn't have any best practice of like how to roll this out or how to share it or how to do that. So we're making that best practice now, and we'll hopefully be able to share that with other teams and collaborate on how to make this work better. So yeah, I think some of these the conversation just before this about there was some stuff about documentation, and sometimes it's nice to have time to do it, but sometimes you're just like, you just have to do stuff so fast you haven't had time to write it down. So we're actively planning on spending the next several weeks just like cleaning up all the band-aids and like writing up how all this works and putting it in a place that's shareable so everybody can access it. So
thank you for sharing that very real view of what it really takes. Lots of time to go to this presentation. Everything is perfect, but this is very helpful. I saw that you had a section up there about asking people for feedback. Was this helpful? I'm curious what your next step is to use that feedback. Are you planning to use it to kind of live update the model, or more like, okay, we're going to collect this and then use this as a feature?
The second one. Yeah, I mean, we're collecting that right now because mostly right now we're using that to like track bugs and stuff like that. But the eventual idea is to be able to use it to actually say, okay, these are places where the model performance isn't what we want, and what features can we do to like actually get that to be better. And one of the things that my coworker Jay has pointed out is like, this is wonderful labeled data. Like we know exactly what it gave, and we know exactly what the answer should be because they told us. And so yeah, we're definitely planning on using that. But it's going to be more of a batch mode sort of thing. Yeah.
One of the cool things that I think Dell does across the apps that they build, like when you see this, it's very much like modern software development. Like it's very iterative. You hack something together, you get feedback, you iterate on it until it's productionizable. But I think one of the things Dell does across their apps, and I don't know that they actually know that they do this consistently, is they write release notes and they capture feedback. So as we've been doing discovery around how Domino can make apps better, I've seen at Dell that they will often, like the data scientists will actually publish release notes as part of every app and give a vehicle to the consumers to actually provide feedback directly to them, which I think that's a good little best practice that makes each of their iterations that much better.
I didn't know that we did that, so that's
Yeah.
good. I mean, I knew that ours did that, but I didn't know it was a thing that we
Elders
did.
does that too.
Yeah, that's awesome. Yeah.
Before launching it to all 10,000 users, did you do any validation or A/B testing? I mean, like, does it help with the metrics? Are they better for some?
So we did some, we did originally train this model. When we started this process, we were in the middle of Q3, and so we used Q2 and Q3 data. And because we were doing so many things at a time, kind of Q4 got completed before we realized it, and we were like, hey, now we have this pristine test set. So we like ran all of the models on all of Q4 and saw what all of the outcomes were, and then evaluated some of those metrics. The repeat rate is the one that actually most of the executives care about. If we can solve the problem the first time, it's better for everybody, and that's what we care about the most. And we did see that in places where the agents, so I don't like to say where we got it right, because sometimes like what the agent does and what the model predicts are different, but not because we're wrong. Sometimes it's because they're like close, but not like they're both valid or something. But we're in the aggregate, when the model matched what the agents did, the repeat rate was lower than when the model disagreed with what the agents did. So that means to us, like the way that we interpreted that is that, okay, in places where if we had just deployed this, those would have given us the best practices. So well, thank you guys so much.